Hello, in this series, I'll be solving pure math, pure mathematics, that is CIE A-level, that is for October, November, then 2022. So you have to follow me from the start to the stop so that you can be able to get everything that goes on over here. So in case you don't understand, you can feel free maybe to have some other concepts explained to you in a better way. So I will quickly go to the question. Then from there, you can try to compare your objectives from the start to the stop when maybe you make a decision to watch this tutorial. So the first part, the first question, that is question 1A, you're asked to sketch a graph of y equal to, we have got the modulus of 2x plus 1. So guys, when you're asked to sketch a graph, you have to adhere to the following rules. You have to look for the x-intercept, and the x-intercept of any given curve or line is the value of x when y equal to 0. So we can substitute, we have 0 equal to modulus of 2x plus 1. So when you're solving for this, you can either have plus or minus 0 equal to, you can remove the modular sign so that you can have 2x plus 1. So 2x plus 1 is strictly a 0. And if you solve for x, you'll get the value of 2x equal to negative 1, which gives you the value of x to be negative 1 over 2. So already we have our x-intercept. So we have to go on and look for our y-intercept. So how do we get the y-intercept? So this is how we get the y-intercept. The y-intercept is the value of x, is the value of y when x equal to 0. So for this case, you're going to have y equal to the modulus of 2 times 0 plus 1, which gives you y equal to 1. So we can illustrate these ones in a Cartesian plane, just a rough sketch of it. So I'll just draw a straight line here. Okay, that's a poor timing, so let me just draw a perfect straight line. So we're going to have like that. Then I have this. So these ones are my axis. This is the y-axis and this is the x-axis. So what to do, I will indicate. Here we can have one division. Then here we can have one division. Here you can have one division, and then here you can have one division. So this is our origin. So I want to draw this. I want to sketch this curve. So we have negative a half 0, which is halfway here. Then you also have 1 0, which is here. So when I draw, I'm going to have a straight line like that. Okay. So this negative part should not be there because this is a modulus function. So we have to ensure that we are accurate when we are drawing. Okay. So for this side, the curve has to come from above like that. So it depends on the how you are sketching. So this one is a sketch for y equal to, that is 2x plus 1. So that's how we sketch that curve. So I'm going to solve part B. So part B, you're supposed to solve the inequality in part B. Solve the inequality. We have 3x plus 5, which is strictly less than, that is a 2x plus 1. So what do you have to do in this case? So to solve this equation, you only need to understand that the concept of modulus. So like the modulus of any value of x is actually positive x. And also again, the modulus of negative x is a actually positive x. So in other words, it means that mod x is always x when x is either less than 0 or x is x is greater than 0 or x is less than 0. So this law will always hold. So if you remember this, you stand in a high chance to get the solution to this problem. So what are we going to do in this equation? So you can have negative 3x plus 5. We can negate this part here, and then we have equal sign. On the other side, you can have 2x plus 1. So if you collect the like terms, you'll get negative 5x equal to, yeah, we're going to have negative 5x, huh? Because it's a negative 3x minus 2x, which is giving you negative 5x. And then in this case, you're going to have 1 plus 5. You know, this one here, it will be negative 5. When you take it to the other side, it will be plus 5. So you get negative 5x equal to 6, and therefore the value of x simplifies to 6 over 5, and this is a negative value. Now, let's solve for the other value. Solving for the other value is easy because you made this one to be negative. Now it will be positive for this case. So which means you're going to have 3x plus 5 equal to positive 2x plus 1. So in this case, if you group the like terms, you'll get 3x minus 2x equal to 1 minus 5, and this gives you x to be negative 4. So you'll get the value of x, that is greater than negative 4, but strictly less than negative 6 over 5. But we have to use our sketch to identify what's the solution that we should rely on in this case. So I will carry that solution here for the sketch. So we had this sketch. So this is the x-axis and this is the y-axis. So here we had 1, this negative 1, and then here we had 1, this 0, and then here we can have 1, and then here we have 1. So our sketch was like this. I'm sorry, over here it has to be negative 1, and then here we can have something like that. So you realize, like, how can we identify the solution for this? The perfect solution in this case. You see, like when you draw the line for y equal to 3x plus 5, it will be a sloping curve. So maybe let's sketch it here. So y equal to 3x plus 5. So when x value is 0, y becomes 5. So 0, 5, it's up here. Yeah, we can assume it's up there, but now this is not a reasonable interval. Let's assume that it's maybe somewhere there. And then let's get our x-intercept. X-intercept occurs when y value equal to 0. So you can say 0 equal to 3x plus 5. Therefore, on this side, you can get negative 5 equal to 3x. If you divide both sides by 3, you'll get the value of x to be negative 5 over 3, which is roughly negative 1.666. So which means it's outside here. It's outside here. Okay, so it's somewhere here. So when you draw it, you realize that you're going to have this part. So what happens in this case? We only have one solution, like one point here, which is a value that's less than negative 2, but is more than negative 1. So it intersects at one point. And that's why we are going to pick only one value as the solution. And therefore, our only valid range, it would be x strictly less than negative 6 over 5. Okay, so in the next tutorial, I'll be solving from question 2 onwards. Thank you for this time.